Good evening, everyone. I'm Scott Kellogg, and I'm the co-founder of GEM Biosciences, along with Bob Langer and Gio Traverso. GEM Bios, it was kind of resonated with me earlier today when we talk about having maybe too many opportunities. And this platform really is an incredible platform that has multiple indications and multiple opportunities. But essentially, it's it's an overlap between Bob's lab and Gio's lab, where you have basically control release properties in a novel matrix, where that matrix actually is releasing in a controlled fashion therapeutic gas. And this always takes people by surprise, but the gas that we're actually using is carbon monoxide. And everyone looks at carbon monoxide and say, oh my goodness, that's poisonous. But in reality, there's actually decades of proven clinical literature supporting the properties of carbon monoxide as being anti-inflammatory, improving wound healing, actually in areas of tissue regeneration and tissue protection. So it's actually quite a compelling therapeutic. There's just never been really a commercially viable platform for it. You can't have people walking around carrying a tank of poisonous gas. So the technology that came out of MIT essentially allows it to be delivered in a safe and controlled fashion. So we're looking at sort of our first opportunity as diabetic ulcer and chronic wounds. Like I said, with multiple opportunities and multiple shots on goal here, we really looked for what was sort of the low-hanging fruit and where was there white space in the industry. And if you look at healing, healing's sort of bound on two ends. On the left, you have very inexpensive, sort of traditional dressings, maybe more advanced gel dressings, and then on the right you have therapeutics, but then you also have bioengineered tissues. And on that left side of the spectrum, you have these inexpensive solutions that may cost $100 for a week's worth of treatment, and you may use that for multiple weeks. The problem is that you have about a 22% success rate in the clinic, and then the patients advance to more aggressive forms of their ulcer, which leads to really horrific outcomes, including amputation and even death. On the right-hand side, you have these treatments like bioengineered tissues, where you have multiple applications of a tissue graft, and you have multiple grafts. So this therapeutic can be on the order of $25,000 for a diabetic ulcer. And what we saw was this white space, which was an opportunity to have a highly effective solution for a low cost. Really looking now to take money out of the system immediately. So we're in the process now of raising $12 million over the next 3 years. We do have some seed money already from E14. And when we have our commitment to $3 million, we will start full operations. Without going into a lot of detail on diabetic foot ulcers, it's a big problem in the United States. About 1.6 million Americans are diagnosed with a DFU every year. If you look at sort of these advanced wound cares that distribute about over $12 billion in the care of these ulcers. And as I mentioned just previously, the bioengineered tissues, maybe 50-60% healing rate. We want to get to a 60% healing rate, maybe a cost of $3,000 total for the whole procedure. Here's our technology. That was really the work primarily from James Brine, who developed the materials in Gio and Bob's lab. We can actually build these as gem foams, solids, or hydrogels. These entrap the carbon monoxide gas and then release it in a controlled manner. And by tuning basically the properties of these novel materials, we can also control how much gas is released. In the preclinical work that we've done, we see highly effective healing rates. This on the lower right here is a model, murine model, diabetes-induced murine model. And you can see that compared to control, which is more of a standard of care dressing, that we have superior wound healing and contraction of the wound in 10 days. Beyond this, we've also looked at basically preclinical work for Tylenol overdose, and we see that by giving a pre-dose of the gem foam rectally into the mice, we actually can preserve their liver from being destroyed in the Tylenol overdose model. We very clearly see destruction of the liver without the gem, and with the gem, the liver is essentially healthy. Also, in the GI space, which is aligned with Gio's work and interests, we see this as actually reducing inflammation associated with ulcerative colitis. So we've induced ulcerative colitis, a DSS model in mice, induced the colitis, and when you apply the gem foam, similarly, it basically reduces all the inflammation, and the structure of the GI actually looks, intact. So, MIT, as always, has excellent patent portfolio for this. There's also patents that have come out of University of Iowa, where James Brine, our business partner, is now a practicing radiation oncologist. As I mentioned, we've received seed money from E14. We've submitted a direct-to-phase 2 SBIR also in January, and we have ongoing investor discussions. As we build out our team, and as we've typically done now, Skip's here in the audience today too. This is our 6th or 7th life science startup, and we always sort of build out the top KOLs, our clinical advisors. Right now, those clinical advisors are directed, at wound and dermatology from Harvard Medical School, Joslin, and also UPenn. And then we've worked for a number of years with David Feigl, who's had the distinction of running, basically all divisions of FDA at one time or another. So we also have advisors that are sort of leadership in finance and BD and clinical and reimbursement that are working with. In a nutshell, the competition, as I kind of alluded to, you look at sort of the gauze and the gels and the alginate dressings. These are very inexpensive. And basically have a 24 to 31% healing rate. You go up a little bit of level and complexity. You have negative pressure wound therapy. That's also much more expensive than what we're proposing. Slightly better outcomes. And we want to basically have the same outcome as you have with the bioengineered tissues. Our immediate plans now are to basically secure our Series A round. We will start operations with full $3 million, and we want to actually get into a proof of concept OUS in a human trial with that $3 million. Thank you.